without wasting any time, welcome to the fourth AI Fairness and Bias webinar. We are the Pan-Africa Center for AI Ethics. My name is Khathabile Tshepe. I am the moderator for this session. So what is Pan-Africa Center for AI Ethics? Our vision is shaping the future for Africa's AI landscape to reflect the ethical and responsible dimensions of the African society. And then our mission is, the center's mission is to ensure that AI design, deployment, and use align with Africa's ethical standards and value. We are committed to promoting human-centric AI within the African continent. What do we do? We are committed to ensuring the ethical development and advancement of responsible AI. Our organization focuses on key concepts related to fairness, accountability, transparency, and overall human welfare. This includes normative values, concerns, and potential risks involved within AI integration and optimizing in Africa. We provide coverage on issues associated with the African experience, culture, interactions, and perceptions on AI tools and their deployment. So without wasting any further time, ladies and gentlemen, I would like to welcome Luis Moses, who will be facilitating the webinar today, the AI Fairness and Bias. And over to you, Luis, you can go on.
Okay, hello everyone. I will just be sharing my slide. Please give me a moment. So I hope you can all see the slide.
The slide, we can't see the slide. I'm not sure if I'm the only one, Luis, but there's nothing on my screen.
Okay. Is it visible now?
No.
But the problem is showing that slide is already being shared from my end. I will try joining back in maybe so that maybe if there's any problem I can rectify that.
Yes, now we can see the screen.
Okay. So welcome everybody to the Pan-African Center for AI Ethics. I'm going to be taking us today on AI fairness and bias. But before we go into AI fairness and bias, I think it's important to note that AI fairness and bias are important matrices, especially now that AI ethics is gaining more cognition. You see that people these days are more willing to talk about whether or not an AI is fair, whether or not it's discriminating a section of the population, whether or not it's discriminatory based off of people's I'm sorry, am I echoing? Can you hear me clearly?
You are clear, Luis?
Okay.
Yes, we can.
Okay, thank you very much. So the concept of fairness and bias is very important, like I was saying, because if an AI model isn't seen to be fair or is seen to be biased in any of its matrices, in any of its parameters, the thing is that it will produce incorrect outcomes, it would discriminate members of the population, and at the very fundamental, it wouldn't give the designers or the developers of these machines the results that they hoped for when they were designing them. So let's go straight into what AI fairness and bias is all about. So what is fairness? Fairness can be seen from different contexts because it concerns some protected attributes. What this means is that fairness is not just about what you think is fair, but it covers certain a whole lot of matrices. It covers ethical constructs, it covers value systems, it covers legal regulations that are used to achieve a set of outcomes. So where an AI model isn't seen to um, fit into all these categories, it could be said that such an AI model is not fair. Machine learning inherently tends to engage in ethical fading. Ethical fading is a concept where ethical considerations are being replaced with practical or financial reasoning. For example, maybe a big tech corporation could decide to prioritize its finances, its profit making over its ethics. And in such an instance, we could say that fairness is not present in such a model that was designed with profit making in mind, not regarding the sensitivity of the culture, the society where the AI model is to be deployed. Bias is on the other end of what fairness is about, because like we know, fairness is more or less a positive outcome, while bias is negative. So bias refers to a systematic error in decision making that could produce unfair outcomes, or it could reinforce existing inequalities. Bias could arrive at different stages of the training, development, and use of AI. It could be at the data collection stage. Maybe the data collected excludes a population. It could be at the algorithmic design stage. Maybe interpreting the data into algorithms. Some parts of data sets are maybe lost or not interpreted um, the way that the developer envisions. It could also be based off of human interpretation. What this means is the end users themselves see the systems as biased, regardless of the fact that maybe the developer or the designer did not have any intentions or did not spot any of such errors when they were developing and designing these systems. Machine learning models, biases can be replicated from training data, and it could present unfair or discriminatory results. For example, like I said, the person collecting data may have personal biases. Maybe they have some stereotypes or assumptions about some persons or some situations or whatsoever it is. And this could trickle down into their designing of the AI models. It could also be at the design stage where the data doesn't adequately represent a demographic. We've seen instances where AI models have been deployed and people make some complaints, maybe facial recognition tools, and then some people say they try to use these tools and their faces are not recognized or they are being mislabeled as not who they are. So in those instances, we can say that bias has occurred. Another instance of bias could be where external data sets are used to model context-specific AI. What this means is that where the data set is not attuned to the context in which it is to be used. For example, if maybe data collected is to be used in a hospital or in a medical center and is supposed to be used for patients, and maybe the data set doesn't adequately represent all the patients it's supposed to represent. Maybe a set of patients are left behind. Then in that instance, we could say that bias has occurred. Now, it is important to know that bias is not always consciously perpetrated, and it could occur even without prejudice or any form of discriminatory intent. Sometimes the developers may not necessarily be biased themselves, but they could have a situation where maybe there's lack of diversity on the design and development team, or maybe the biases could slip subconsciously based off of assumptions that they've had when training these models. Bias extends beyond just mere data representation and target demographics, and it could have some ripple effects. For example, maybe in hiring processes, could have some effects, maybe in medical centers where it's being, some persons may be excluded or others may be included even when they ought not to. So these are all instances where bias could occur. Fairness and bias in ethical context. So rapid adoptions of AI tools necessitate the need for fairness and avoiding bias in everyday applications. Fairness, when it comes to an ethical concept, is more or less viewed from a social lens, while bias is viewed from a technical lens. What this means is that fairness is seen from the value systems, perceptions of people, what is acceptable and what is not. But for bias, it could be mathematically determinable, it could be calculated. Bias could be it could be determined based off of mathematical constructs. So it is possible for you to determine the extent to which a bias occurs, but it's very difficult when it comes to fairness because it's a social concept. So, like we said before, the negative effects could trickle down. For example, maybe a person is maybe in a hiring process, a person is biased in their designing of an AI system, and some persons do not get hired. This could have some long-lasting effects on them. So we see here that fairness is something that it could have some form of social effects that could last for a long while. Then sources, will go into sources of bias. So there are different ways in which bias can trickle into designing and developing AI systems. But here we just decided to list 5 of the most common ways that we could see bias occurring. First one is sampling bias, then we have algorithmic bias, representation of social bias, confirmation bias, and measurement bias. So we'll be looking at each of these biases, what they mean, because it's very easy for people to just say bias, bias, bias. But the truth is, biases are different. They could come up at different points in developing, collecting data, um, interpretation of these systems. So it's important for us to realize where bias will come from, because when we're able to do that, then it helps the developer or the designer know where such biases can be found in the AI system. So we have sampling bias. So sampling bias occurs at data collection stage, like the word implies, the sampling data that is being collected. Maybe it doesn't represent all the target population. Maybe some persons are excluded. For example, maybe we're taking data of all the persons living in a particular area. Let's say, for example, all the persons living in Lagos State, Nigeria, and we exclude some persons maybe based off of their zip codes, where they stay, the localities in which they stay. In such instances, you can say that bias has occurred even in data collection stage. So we see here that bias can occur at almost any stage. And when bias occurs at the most fundamental stages, we see that the effects could be enormous because it could just keep multiplying when these algorithms are deployed. The outcome of sampling bias is that the test results could be overgeneralized. For example, if we collected test results of all the persons living in cities and we left those living in the urban areas, the result of that would be that whatever outcomes or decisions that the AI system arrives at, it will be excluding the realities of some people because they weren't even included when such data was sampled. We have also algorithmic bias. So algorithmic bias is a form of bias that is present in the algorithms itself, and it could occur based off of maybe limited data that is used to feed that is used to train the AI system at training stage, or maybe the algorithms, the data isn't adequately represented when it's being transferred to algorithm form. And in such instances, it could favor a group of people over another, could also exclude groups of people, or it could justify harmful outcomes. So, like I said before, bias isn't necessarily just about excluding people. It could be about favoring some people or over including some people. Maybe there, for example, um, where we have an AI system that maybe some people complain that the data doesn't adequately represent them. It could also be doing a form of harm to others because it could be over representing others. So in that instance, maybe like facial recognition that maybe over represents white people, for example, when they pass through security checkpoints and all of that, the bias could also be in their favor. So we see that that's a form of bias. It doesn't necessarily mean that bias is always a negative outcome. It could be positive in itself, and it could also justify harmful outcomes. For example, maybe the AI produces a result that is biased, but because people tend to rely on AI systems and believe that they can make mistakes because these are mathematical systems, the problem with that is that it will be justifying harmful outcomes. It will be making, I don't want to use the word justification, but um it will be backing up the reason why those harmful outcomes came about the way they came. So it will be easier for people to make references to say, oh, the reason why this thing happened like this is because the AI system produced this result, not realizing that the AI system itself could be biased, could be overly confident. We have an example of that with ChatGPT, for example. When ChatGPT was first designed, people could tell that there are times when you would ask it some context specific questions and would provide some answers that they were outrightly wrong, but it would go ahead to justify these answers. There was a US case where a lawyer was able to um, curate some distinct cases, some previous historical cases based off of an AI. But when he went to court, it was discovered by the judge that these cases did not actually exist. But ChatGPT was able to generate these cases and even provide facts on what happened in the case. But these were cases that did not even exist in reality. We also have representation and social bias. So I think this is the most common form of bias that most people understand, because this bias has to do with data collected that excludes maybe certain groups of people, or it's not diverse enough, or outliers or anomalies are not taken into consideration. If you are collecting data, it's not enough to just collect data based off of just the usual things that happen, maybe the usual experiences or the persons that you expect to see in the target demographic. You also have to collect data based off of random samples, because if you don't collect random samples, these are things that occur even in reality, right? If, for example, you are collecting data of students in a hostel and you just collect data of the students there, not realizing that some students may be living outside of the campus, these people may be viewed as maybe outliers because they are not necessarily following set down procedures of staying in school, but they are still students nonetheless. So where data is collected excluding them, we could see bias happening in such instances. Then we also have confirmation bias. Confirmation bias is the tendency to interpret information in a way that reinforces pre-existing beliefs or assumptions. This tendency could lead to disregarding data that does not support these beliefs, however true or consistent they may be. Maybe an AI system is able to churn out some information that reinforces something we've previously believed in. For example, we have echo chambers, right? If you keep Googling, maybe you keep Googling, you are researching on something and you keep researching based off of one perspective. The truth is, the algorithms, there's a tendency that they may begin to dish out information and data based off of what you've been researching on. So you may not be privy to see the other side of the story. You're not privy to see the other perspective that other people may bring to it. Then we have measurement bias. So measurement bias is when there's inconsistency in the parameters or variables used for a study. This form of bias could be data distortion of maybe an image, or maybe inconsistent annotation when it comes to labeling of data. Maybe the data is not properly labeled. The result of that will be that there will be a bias when it comes to interpreting such data. Okay, so we'll go to types of bias. So after seeing what the sources of bias could be, sampling, algorithmic, and the likes, there are different types of bias. And the National Institute of Science and Technology groups bias into three main sources. If you try to read up on, further readings on these biases, you see that there are several types of bias, but generally they can be grouped into these three categories. First one is systemic bias. Systemic bias originates from past practices and procedures within an organization that tends to favor some groups of persons over others. It could be historical, it could be societal or institutional. For example, where a company is used to hiring male candidates. In an instance where maybe they use an algorithm for its hiring process, female candidates could be possibly excluded because based off of the historical nature of the institution or the organization, they are not adequately represented. So the algorithm is just going to assume that female candidates shouldn't rank on equal scale of priority as their male counterparts. Another example of this, aside racism and sexism, could also be infrastructure inclusive environment to support persons living with disabilities. Because we know that people living with disabilities are historically discriminated when it comes to when it comes to hiring processes, especially in corporate organizations. So we could see that these forms of biases could trickle even down to AI itself. Then we have computational and statistical bias. This form of bias is where there is poor data sample or there is poor representation in the data sets. This could be as a result of the algorithms bias, but sometimes algorithms could be trained on heterogeneous data that doesn't include, like I said before, anomalies, outliers, and all of that. So it's so oversimplified that the results are exactly what designers or the developers expect, but it wouldn't make instances for maybe random results or random happenings. Let me give an example. If maybe there is an AI that is trained and the result it's trained off of students, did I say, performances in the past, and this data is trained to predict what each student would score in the exam because of previous maybe their previous historical data. What could happen is that students that maybe haven't done so well in the past, they could the prediction analysis could be that they would not do so well in coming exams, and you wouldn't take into account the fact that maybe they have been reading up more, they've been taking extra classes and all of that. Then we have human bias. Human bias is like systemic bias, social and cognitive in nature, and it could influence decision making. This form of bias could be from the developers themselves. It could be from groups, organizations, and it relates to how people perceive AI information or AI systems. So where an AI system is perceived to maybe favor groups of people over others, maybe groups of people that have college degrees will be favored over those that don't. In that instance, we see an example of AI bias. So we'll move to matrices for detecting bias. So there are several matrices that designers and developers of AI systems use to know whether or not an AI is being biased when they're training it. So these matrices are important because once they realize that maybe there could be some forms of bias manifesting, the parameters used could be adjusted or the data sets could be adjusted to adequately reflect what's a fair result, which is what the developers or the designers would ordinarily expect. So we have demographic parity. Demographic parity means that there will be an equal selection of protected classes for a positive outcome. So here, all forms of protected attributes will be removed so that the data set will look at the data set to see whether or not it will produce the same result when protected attributes are being removed. So it's best to use this kind of form of matrix is best used to prevent historical bias, especially where it is used to determine the quality of data. Let me give an example of this. So if, for example, we have an organization hiring employees, and some of these employees are men, some are women, some are graduates, some are maybe they just have a secondary school degree, they haven't yet gone to college. In these instances, the AI system in preventing this form of bias will be looking at their qualification based off of what they have. It's not looking at their protected attributes. It's not looking at the fact that maybe somebody has a degree and another person doesn't, because in doing that, it could be biased against the person who doesn't. So it could be looking at the other person's skills, what that person has to bring to the table, because in that instance, even the person that has a degree will have skills, out of school skills, and then the person that doesn't have a degree will also have the same thing. So such forms of data sets, what would be used or what would be recognized instead of looking at who has a degree, who doesn't have a degree, or maybe their outputs in their previous job positions will be used instead of just looking at maybe their qualifications or their rankings. Then we also have equalized opportunity. So equalized opportunity here, what it does is it selects the parameters of true positivity for each group at equal rates. I give an example here, let me read this out. So I said here that offering loans to all teachers and lawyers earning over 1,000 naira. So where there are not enough lawyers earning that amount, some earning less may be introduced to the data set to balance it with the number of teachers that are earning that same amount. And then from there, maybe the algorithm make its decision. Now, the problem with this is that those people that are not earning up to 1,000 naira may be used to overcompensate so that we could have equal parameters, and then the data could be pulled from there. So that is one of the disadvantages of equalized opportunity. Equalized opportunity would be seeing, I want to use a layman term, so it's been looking at them from their areas of strengths, areas where they all have their strengths, for example, but those strengths are similar or the same. Maybe all of them are, maybe all the persons that are applying for a job, for example, are all college graduates. So we'll be looking at that as the parameter instead of maybe looking at who is earning more or who is earning less. Now, the problem with that is for those that are earning less, maybe because their output wasn't good enough at their previous place, or it wasn't as good as others that are applying, they could inadvertently seep into the data set. So we see that it could provide for some imbalance. Okay, then we have equalized odds. So equalized odds is also called equalized accuracy, and it refers to groups that have same true positives and same true negatives. Maybe they have similar characteristics that run true for each of them. For example, maybe we have 50% of male applicants for a job, maybe unqualified, but another 50% of female applicants may be qualified. So in that instance, the data set would seem balanced, and then from there, the algorithm would make its decision because we have the same number of persons that are unqualified, then the same number of persons that are qualified, which is what we refer to as positives and false negative results. The result of this is that it could produce a very high level of fairness, because then we're not just looking at maybe the characteristics that each of these persons has. We're also looking at the characteristics that they don't have and ranking them on an equal scale. For example, if all of them were, I'm going to use an example of students, if all of them were all A students, these are all characteristics they have. But if all of them, maybe they didn't take extracurricular activities, we'll also be using that parameter alongside the fact that they are all A students. So we see that there's a form of fairness because we're not just looking at things they have in common, we're also looking at things they don't have in common. So it produces the best form of results we can possibly get when it comes to bias and fairness. It is used usually where there's a strong need for positive outcomes or where the target variables are not subjective. Where target variables are subjective, it will not be advisable to use such form of metrics. For example, where you are measuring students based off of their contributions in class, right? These are subjective because I could be contributing more in one class, for example, because I enjoy a teacher's lessons, but I may contribute less in another class because of that. I may be contributing in other activities that may not be classroom activities, and those things are they may not be measured. So in that instance, we'd say that equalized odds has a form of advantage rather, because they are looking at the fact that things that are things that are not subjective are what they are using to measure. But when something is subjective, it depends on a person's perception of it. So it will not be up to developers to decide what they perceive of the data set, and that's what they use to train the data set. Then we have group unawares. So group unawares is a technique that disregards disparities in groups when making decisions. A good example of this is hiring based off of merit. So in that instance, we're not going to be looking at protected attributes. We're not going to be looking at even just maybe general attributes or features that distinguish each of the data sets. So if we are looking at based off of merit, we're not going to be looking at, oh, are women in this hiring system? Are men in this hiring system? Are these students are these students having the same performance? Are these employees of the same age? Are there some that are younger or some that are older? It's just going to be doing its analysis based off of merit. But the disadvantage in this is that for communities that are protected or that are communities of persons that are protected, communities of persons that maybe they've been historically disadvantaged, they may have some form of disadvantage when this data is trying to interpret itself. I give an example here where I said, if you're having CEOs based off of merit, you'd see here that it would disregard women and pick men more. It would also disregard Black people and people of many minority ethnicities, because these people have historically not been in low positions. So they don't necessarily have the skill sets as required. They've not been in managerial positions. So that merit in itself, it could pose some problems for protected groups of persons. So go to tools for checking AI fairness. So there are several tons of tools that you could use to check AI fairness. And I just listed out three here. Um, Microsoft Responsible AI Dashboard. We had a lesson on that last week where we looked at, we looked at some matrices, and it's we also have Fair Learning and we have AIF. I think Fair Learning is also from Microsoft, if I'm mistaken. Yes, it's also from Microsoft. Then we have AIF 360, which is an IBM product. Now, the different tools for checking fairness, they could be based off of different matrices, like we've said before, right? Some could be looking at maybe protected groups of persons, protected attributes. Some could be looking at other parameters. So it depends on what you want. What you want will determine the kind of tool you use. Usually, the matrices that are used to check fairness are that are ideal in checking fairness are that you're looking at the AI model that you want to deploy. You're also looking at the data. That's the data set that you're feeding into the AI. The data set is very important because if you don't have the right forms of data sets, then it will be impossible to check the levels of fairness and to estimate the amount of bias that is present in the AI system. Then we also have the results that you want to achieve. So it is not enough to just have maybe a model and to have data sets. You also have to think about the results you want to achieve. What exactly do you want to do? Because the thing with fairness is, in as much as you strive to have AI systems that are fair, you can never fully bias an AI system. AI systems will always have some elements of bias, but the onus is there on us as AI ethicists to make sure that these biases are mitigated. These biases are so minute and so little that they are not easy to spot, or they don't disadvantage protected groups of persons, or they don't disadvantage persons that ought to merit something, or persons that ordinarily should be selected in a selection process. So um, these are important things that you have to look out for when you are trying to determine the tool that you use for AI fairness. And another thing that may be useful when you're looking at the tool for AI fairness is what the model will classify as a protected and unprotected attribute. For example, a protected attribute could be maybe that maybe, like we said before, minority groups of persons, right? They could be protected attributes because maybe you don't want an AI system that flushes out all women or maybe all persons with disabilities. So in that instance, you have to make conscious efforts that when you are training the AI system, that these protected attributes are not lost in the process. They are not maybe removed, maybe because of group unawares. If you're using group unawares, for example, that's why I said these things are important. You can't use group unawares because in that instance, you're looking at things based on merit. And when you are looking at merit as your outcome, then some people will be shelved out, some protected groups of persons. So you may have to look at maybe equalized odds in trying to achieve this fairness that you want from your AI system. So these tools that I said are used for checking fairness. They could, we have Fairlearn. Fairlearn, like I said, is from Microsoft, and it could mitigate fairness for classification models and for interactive. It could also help with interactive database. So the database, it's much easier than what you may have with some other forms of tools that may be a bit more complex. And at the same time, companies also could make use of various matrices. So the advantage of that is you don't just necessarily have to look at one matrix. You could put in as much protected attributes as you want. You could also put in, or and you could also take note of all the matrices you wanted to take note of without losing the substance of what you want outcome. Then we also have AIF 360. Like I said, that's from IBM, and that one is used to examine, report, and mitigate bias in machine learning. throughout the AI life cycle. It could be used during the data collection process, during the training process, even during the feedback process. So that's an advantage of AI 360. It's even when human beings, humans identify some form of bias in the system, it could um, make sure that these biases are properly adjusted. Then also we have Microsoft AI dashboard. So for more information on Microsoft AI dashboard, I would advise that our last lesson that we had on responsible AI, go back to it and look at what was said in class. But it's mostly used for businesses um, because of its interface. It's better for maybe business organizations and corporations. I think it's important to note, like I said before, that there is no one AI system that can be without totally devoid of bias, because bias is more or less a spectrum. In as much as you're trying to accommodate some persons, some groups of people, maybe some parameters, you could, in the process of trying to accommodate them, you could be accommodating some others less. For example, if you're trying to create an AI system for hiring where we have more diverse groups of persons, what that means is that for white people, maybe that have historically been represented in the hiring process, there will be less representation of them. So we see that it's never really a win-win situation with bias. But the importance of bias is the importance of checking for fairness rather is that bias is mitigated to its lowest levels to a point where, like we said before, fairness is all about value systems and also about legal regulation. So it can be seen that at least there is some form of fairness in trying to look at different parameters. People can collectively say that the AI system is not intentionally trying to harm or exclude a group of people in its outcome or its result. So the best thing in that instance is in trying to get a fair AI will be that you look at more than one metrics. It's not enough to just say you want to look at the model itself. You have to look at the model, you have to look at your data, you have to look at the results you want to achieve, you have to look at maybe protected attributes and non-protected attributes. So you see that it's more or less a holistic approach. It's not enough to just use one metric because inadvertently your system will be biased. So you have to take note of several matrices, especially those that you think are very important to your outcome. And those are the matrices that will determine what tools you use for checking your bias, um, whether you're going to be using equalized odds, or you're going to be using group unawares, or you're going to be using demographic parity. So I think I'll end up on saying that fairness is also a legal issue because we have in some countries, right, that we have some countries that fairness matrices are requested from um, AI tools, and where AI tools are seen to be unfair, it could lead to legal action. So it's not just enough to say, "Oh, I made an AI tool. I think it is fair." Nobody is complaining about it, or from the data collection and training stage, it was fine. If it doesn't follow stipulated legal regulations, then such an AI system will not necessarily be fair based of the country's legal perspective. Okay, so rounding off now, I'll be looking at some common examples that of AI fairness and bias. I think we're quite familiar with some of these examples. Sorry, can you see my screen?
Yes, Louise, we can see your screen.
Okay, thank you, Ray. So we have the Compass Risk Assessment AI. So this was a clear case of racial bias because the AI system was supposed to be predicting inmates, predicting their likelihood to recidivism, predicting whether or not they would commit a crime again, and that would be what would be used in their judgment and sentence. But we saw in that instance that the Compass AI, which was the tool used to note whether or not these inmates were likely to reoffend, the tool used, we saw that it discriminated Black defendants and they were misclassified as twice likely to reoffend than their white counterparts, even though the results, the actual historical result was different, right? even though the reality was different. The reality was that their white counterparts were more likely to reoffend. But we saw that maybe because of historical bias, um, we saw that they were being categorized as more likely to offend. So they were given a higher risk score on the AI system. Meanwhile, on the other hand, their white defendants were characterized as low risk, despite their higher tendency to offend. So that's what I was saying about bias. In as much as it was discriminating Black defendants in those cases, it was also biased towards the white defendants because it was giving them, did I say, more of an opportunity, a higher ranking, a higher scoring on its system. So it would be easier for judges to, release these people without realizing that they are more likely to offend than what the system tells them. So the outcome there was very wrong, and that AI system had to be reviewed. Then we also have ChatBot. So ChatBot was created by Microsoft and introduced to X, formerly Twitter, and it was supposed to be communicating with Twitter users, and um, the essence of that was to get some form of feedback that they could use to train their systems from data collection. And they realized within 24 hours that the AI had already begun to learn racial slurs. It had already begun to learn some transphobic and anti-Semitic um, words from communicating with users, because users were just constantly feeding it some of these words. And unfortunately for the designers and developers of these systems, they did not create an AI that's cool. They didn't, in their creation of the AI, they did not make sure that some certain words, some certain language or lingo was removed during the training stage. So the AI ended up picking up these language from others, and unfortunately, it had to be shut down. Then we also have the Amazon Recruitment AI. So Amazon introduced a recruitment tool, and that tool was supposed to recruit some of its job applicants. And the problem was, people realized that women that were just as qualified as men for such roles, they were not selected, regardless of the fact that they were qualified as much as their male counterparts. And the reason for that was because the AI had been trained previously on data from past employees. And unfortunately, most of the past employees were men. So the AI already, from the training stage, began to rank women lower in the hiring process because they did not have adequate representation in their workforce. So I think it's important to realize that, um, in as much as there are historical biases are inherent to human nature. We have biases every day around us. But that's the essence of AI. The point of AI is not that it should replicate errors of human beings, biases of human beings, but rather that it should seek to correct our errors, our inclinations. So training these systems isn't necessarily just about training them based off of the realities of our world or our social constructs, but rather that they are being trained based off of an idealistic situation, what should be expected, so that when these AI are trained in these forms, then people that haven't been properly represented in society, or maybe qualifications that people's qualifications that maybe they've been undermined for and all of that, could have it could have a form of representation. These people could be represented in society. So it's not enough to just say we're training the AI system. It's not enough to just say that we are training the AI system um, for what we have on ground in our society, but rather we are training it for what we expect should be the idealistic situations. Because when these AI begin to have fairer outcomes and predictions, then it helps to balance out society. Okay, so I will go to, I think this is my very last slide. Yes, mitigating AI bias. So there are several techniques that could be used in mitigating AI bias. Like we said, AI bias cannot totally eradicate it, but it's only realistic that if we're trying to reduce AI bias, there will be some steps that will have to be taken in the AI life cycle, whether it is in the data collection stage, or it is in deployment stage, or even user feedback, um, even like maybe reinforcement learning and all of that, it's important that we realize that where biases are present in an AI system, it can be adjusted or corrected accordingly so that it will produce the form of outcome that is fairer for most people. So mitigating AI bias could be by various means. First one could be maybe trying to bias the system through fairness awareness and matrices that evaluate performance, or a systematic approach to data collection. A systematic approach could be that when you're collecting data, you make sure that, like we said before, you look out for anomalies, for outliers, for things that maybe data sets that don't necessarily follow follow the regular format, maybe random data sets, because these things could occur in reality. Then also, like I said, fairness awareness matrices. So that has to do with adjusting the AI system. If, for example, you're using group unawares, but you realize that maybe your data set includes persons that are from minorities, you may have to just go for maybe demographic parity, or maybe you could go for equalized odds, depending on what outcome you want to get from the data from the AI. It's important to note, like we said before, that the outcome is very important, because the outcome will determine what form you will use, what parameter you will use in the bias level detection. Then we also have the use of a human input. So human intervention could be useful in reviewing AI outputs and identifying potential biases. Sometimes you could ask for feedbacks from persons, and then maybe sometimes the AI systems, when they are being trained, there could be some form of supervised learning where humans are allowed to go through AI to make sure that it's producing the outcome that it wants to produce. For example, I think this is mostly used in gaming, like creating gamification, where when a game is being designed, we see where they call some people, some experts, to come test these systems out, so that they make sure that the outcome or the output that you had in mind when designing the system, what is actually giving you, and not something else. Then we have algorithmic auditing. So algorithmic auditing would involve regular monitoring and auditing of AI model performances to identify biases. Maybe we could have an organization could possibly partner with an auditing firm or a corporation that would come as a third party to check up on their AI systems to make sure that there's no bias in the algorithms, there's no bias in the data collection, that maybe the organization itself, maybe its employees may not necessarily be able to discover or easily see. At the same time, it could be useful for legal regulations, because I think I said before, yes, I did all saying that legal regulations is very important. It's not enough to say my AI is not biased. That would not fly just because you say so. It has to be that, where there's legal regulations within a country, your AI system is following those legal regulations. Because if it's not, you may not realize it, but it could be biasing some groups of persons. It could be biased in its outcomes. Yeah. So then we also have explainable AI. So explainable AI technique is also important in identifying bias, because explainable AI, like said when we had our webinar on transparency and explainability, the essence of these models are that they are supposed to act as checkmates for other AI systems. So especially large models, like neural models that run with neural networks, they could act as a form of um, checks, as forms of checks for other smaller AI systems, so that maybe they will determine how the AI system arrived at its outcome. So why an AI system is not able to give a cogent reason, is not able to give a reason that you know takes into cognition all the parameters that the designers or the developers of these systems had in mind when they were developing these systems. It could be said that such an AI is biased, whether or not we think whether or not the outcome seems fair on the surface or not, because it's not really just about whether it seems or doesn't seem fair. It's about also the outcome. What was the intention of the developer, the designer? What was the intention of the person that that wanted this AI system designed on their behalf? If it's not able to meet their goals and objectives, then such an AI system may just be biased. So explainable AI could be useful because it will show how the AI system, the smaller AI system, arrived at its decision process. So where the AI system is not able to show a flow in the data collection, in the training stage and the deployment stage, or where there is a flow, but it seems as if the parameters used were not what what were the most important parameters. If, for example, the person developing the system wanted to make use of protected attributes, but discovered that some unprotected attributes found their way into the decision-making process. And these unprotected attributes are not necessarily outliers, like they keep reoccurring each and every outcome process. Then it could be that the AI system will have to be reviewed. Then we also have best practices. So a company could make some deliberate steps to improve its data quality for representation by hiring a diverse team set, because a diverse team set could possibly mean that persons with different qualifications from different backgrounds or different ethnicities, countries, and all of that, they could have different perspectives on the data sets. And it will be useful because in that instance, you'll be taking note of different ways that the end users could possibly perceive these things, because you have several end users. So your direct team set could just be a representation of the perspective that your end users may have when they are interpreting this AI system. Then we also have setting up internal or industry standards and regulations to ensure fairness. Could go by internal regulations. Some, like I said before, some countries have their regulations, but even some, some industries that have their own regulations on what they require for a system to be said to be fair. Like IBM said before, that IBM has their own fairness matrix. So in that instance, it's more or less a company standard that each and every one of their branches would have to take note of when they are developing these systems to fall in line with the company's objectives. Also, maybe some industries like IEEE and all of that would have their own standards and regulations. So if as a developer or designer, you have what's in your mind, you want your system to look like, but maybe you don't necessarily know the biases to look out for. You could look towards these industries and these organizations, try to find out what are the things that they classify to be biased, and also use you could also borrow some of those matrices, apply them to your own system to make sure that your system is biased or fair. So I left some reference and source material. So when the video is posted up online, I believe we'll be able to access some of these. And I'm done. So thank you everybody for your attention. I really appreciate it. And I hope we've been able to, have an idea on what fairness and bias is all about. I know we didn't delve into the technical aspects of it. Subsequently, I believe we'll do that, but this is just, an introduction to what it means for an AI system to be fair and to be unbiased. Thank you.
Thank you so much, Louise. I don't know. I feel like you need everyone to switch on their mic and just give you a big applause. Can we do that, guys, for Louise? Because I believe that this was a very wonderful presentation that she's done.
Thank you.
Thank you.
Come on, guys, can we give Louise a round of applause? Nessie, I see you. Okay, moving on. Thank you. There you have it. There you have it. Okay, Louise, so we're getting into the questions.
Okay. Somebody was asking for the link.
So I think so Rex has a bit of technicality. So I'll just fill in for her while she's trying to sort out uh, sort
Hi,
out.
Kingsley.
Hi, Lord. I mean,
I'm
wonderful
fine.
opportunities for you. Thank you so much.
Thank you.
Um, Good job, good job, good job. All right, so the last few questions we'll just take, and um, I'm just here to the rest is able to fix um, uh, until Ref is able to fix technicalities, and afterwards she steps in. Okay, so from the first question, we have a question on the chat box. Um,
Okay.
with respect to hiring process example, what is your opinion on what firms or organizations should adopt? Because I believe that in as much as companies need to be more diverse in the employment process, there's still a trade-off between these and hiring people based on their experience and skills. Would you suggest any means for firms addressing issues like this, Louise?
I'm sorry, I didn't get everything you said. I lost you at the end.
Okay,
So
I'll read again. I'll read it. The question says that with respect to the hiring process example, I mean, you made mention of a hiring process while the class was going on. So, with respect to hiring process example, what is your opinion on what firms or organizations should adopt? Because I believe that in as much as companies need to be more diverse in the employment process, there's still a trade-off between this and hiring people based on their experience and skills. Would you suggest any means for firms addressing issues like this?
okay, okay. I think I got that. Um, yes, I would agree that it's not enough to say, because we want a fair process in hiring, that we hire persons that are not qualified or persons that do not merit it. There is a trade-off. There's a trade-off because in as much as you want to hire persons from different backgrounds or with different experiences and skill sets, you also want to have persons that can get the job done. The trick about AI fairness is that you're trying to hire the people that have the best, let's say, qualifications, but at the same time hiring a diverse set. So what that means is if we had five people maybe that applied for a job um that were qualified for a particular role, and we wanted to hire from those five people, and we had maybe five white persons and one black person, and unfortunately maybe three white persons and two black persons. Let me use that scenario. And maybe the three white persons were maybe they had managerial positions before and they are trying to go for a CEO role, or maybe they had previous experience, and maybe the two black persons in that position, maybe one of them had some form of experience, but the other didn't have as much. We're not saying you're going to hire somebody off bat or somebody that is not qualified, but what it means is you would make some allowances for historics. You make some allowances for people's backgrounds, because we also realize that black persons, it's difficult for them to have some forms of managerial positions. So you first have to test them to try them out. I Let me give an example. I think I came across something some days ago, a post where they said 90% of jobs can be learned on the job. What that means is that when you allow some persons, if they have the necessary skill set, if they have the necessary background, and you allow them to an opportunity, they could get the job done. So it's not enough to just say that because we want to hire based off of merit, we just hire only merit. We just go straight to group unawares and just pick only people that merit the job. Because what that means is you may not be having a diverse portfolio. You may not be having different opinions on things on your board. You may not be having different opinions for that job position. So I understand what you're saying, that there is a trade-off. There is a trade-off, but the key essence is bias. Is balance. Like I said before, we cannot totally debias systems, but we can make sure that we ensure that some persons regardless of maybe their historical background, they are not penalized based off of their historical background when it comes to opportunities.
Okay, thank you very much.
Question. Kingsley, do you have anything to add?
Yeah. Other things I would want to add is that, as Lois has mentioned earlier, you cannot have an algorithm that is totally free of bias. And when it comes to hiring process, the way it works is that once the bias is introduced into the system, the bias would take through all the activity of the company. So let's say, for instance, the bias in hiring process means that when it comes to granting of opportunities and privileges for people in the company, there will also be bias. When it comes to retirement plans, retirement packages, there will also be bias. And if you are building a model for that hiring process, it means you are building a model that, from the initial have been biased. So all through, the process, and you have mentioned that several factors that can lead to bias. Most times can be social bias and even cultural bias, probably by practice of the company. So the company has practice or policies that we maybe that we view as very, very important to them. And that comes as part of what, they view as, bias. So irrespective, I think what the company needs to do is, as Lloyd have mentioned, we have over 73 metrics for the certain biases. What are the three? That for technical metrics. And for legal metrics, there are countries that have anti-discriminatory law. So it's for us to look at the peculiarity of what you're doing, the peculiarity of what you're seeing, where you're staying, and seeing how you can ensure that your algorithm is properly free from bias. I see that Rex is back. Rex, please confirm if you're able to hear me, take and take over. What is trying to do? Rex, there's another question for you. And the question is, can you shed more light on protected attributes?
Can I share the link?
No, can you share more light on protected attributes? I think someone is not so sure of what the term protected attribute is. Can you share more light on it?
I can't hear you. I'm sorry.
Oh, can you hear me now?
Yes.
I said that someone asked a question on what is protected attribute. You were mentioning um, protected attribute, protected attribute. What does it mean?
Yes.
More light on
Protected
what
attributes. Protected attributes are like features, or would I say parameters, that when you are designing your AI system, you don't want them to be lost in the process, in the data processing. What that means is when you're collecting data, for example, maybe there are some certain groups of people, or maybe there are some certain qualifications, some certain things you are looking out for in your data set. You don't want it to be lost when data goes through, the training stage down to the deployment stage. So these attributes, they are protected because you make sure that in instances when you are training the data, they are always present. In instances where you are using tools to check data for any forms of bias, they are always present, because where they are not present, maybe the outcome of the data of the AI may not be desirable for you without those attributes or those features. um, Let me give an example. If you have a data set that maybe you want, I don't want to use the word employees anymore. I've been using employees a lot. Maybe you want to check for patients in the hospital, that patients that have cancer, right? And maybe you're trying to run a test with your AI system. You're trying to find out whether or not the likelihood of a patient to have cancer. Now, you may be checking through all the patients in the hospital, but a protected attribute may be maybe patients that come in 3 times a week, or maybe even outpatients, for example. Maybe there are patients that you are so sure that you want to keep them in your data set. You want to keep that representation in your data set because it's important to your outcome. If maybe you have some outpatients, we know that some patients, maybe they may be sick, but they get to leave the hospital and come for regular checkups. So you don't want those patients to be excluded in your data set because you realize that they are very important, even in that cancer detection of likelihood of patients to have cancer. They're very important to determining your outcome. So in every instance of training your data, you make sure that these persons are represented so that you don't lose that substance of what you're looking for. I hope I've been able to clear that.
Okay, yes, you can take over.
Thank you for that, Louise. I'm sorry. No, you can.
Can anybody hear Lois? Can anybody
Thank you for
hear?
that, Louise. Can you hear me?
Yes, I can.
Can you hear me?
Yes.
Okay, I'm so sorry for just disappearing. I had a minor technical issue, but I'm back on. Do we have more questions to ask Louise?
I think somebody asked for the link for the presentation, but I'll just say that, it's the recording, two people asked for it. So it's going to be shared on our YouTube channel. So you can just follow us, Pan African Center for AI Ethics on YouTube, and it will be made available at least before Monday. It should be ready.
Okay, okay, okay. I'm trying to share my. I'm trying.
Great.
I was saying that I'm trying to share my screen so that we finish off with the announcements and everything else, but I'm currently experiencing a challenge. May I please ask Kings, can you please just help me with?
I don't know if Kingsley could help with that. Kingsley, can you help with that?
Not sure I'm able to. You just continue with other slides. Let's continue with other slides. I'm ready.
Okay, no problem. So there you have it, ladies and gentlemen. I hope that this was a very informative, that you found this webinar informative. And if you have more questions, don't please just follow our social media page. And there is also a link to our summer school that will be in August. And if you're also interested in joining, there's a link that you can use and join and sign up, and then more details will be posted on our social media pages.
Can you see my screen, Red?
Yes, can you please the social media so that they can see the link?
Okay.
Yes, so these are the pacfaie@gmail.com if you want to reach to us, and then we have the social media handles, the LinkedIn Pan Africa Center for AI Ethics, and then the Instagram at PACFI, and X, formerly Twitter, at PACFI. So please don't be afraid to get in touch. Send us an email, like us on social media, and also please register for the summer school. You don't want to miss that. And if no one has any questions, I think this is it, guys. Thank you so much for joining, and we really appreciate your attendance, and we're looking forward to seeing you in the next webinar. Thank you.
you.
Thank you, Larry. Thank you, Ray. Have a good one.
Thank you. Bye, everyone.